Okay, good morning everybody. Okay, so this is the last topic for today. Yeah. Okay, so chapter 7 coordinates. So the last one that we have today is 7.3. Okay, area of polygons. So I hope you have done all your exercise. Okay, so this is the last part before you come back to school next week. So those who haven't finished your work, okay, I hope you do that before the school reopen. Okay, so chapter 7, we have two subtopic. Okay, three subtopic. Two we have done. Okay, so today is the last one. So first thing is area of polygon. So first thing you have know, right, what is polygon? Okay, so polygon is any shape, okay, any two-dimensional shape which is enclosed. Okay, what is meant by enclosed? If we see here, okay, so this is one polygon. Okay, triangle. So when we say it's a polygon, it means that it is enclosed, so all the point is joined. Okay, so if previously we are looking at straight lines and line segment. Okay, so now we have all those lines, okay, and we join them together in an enclosed shape. So when it is an enclosed shape, we call them polygon. Okay, so polygon, it can be regular or non-regular. Okay, so for a regular polygon, we have formula for it. Okay, to count to calculate the area. But now if we have a non-regular, something like this, okay, something like what we have here, okay, A, B, C, okay, this is a triangle, but the shape is not regular. How to find the area of this polygon? Okay, so if this polygon is drawn on a Cartesian plate, okay, Cartesian plate means it has this x-axis and the y-axis, okay, means the point will have coordinates. Okay, so I will let the A, B, C, the point as x1, y1, the point B as x2, y2, and C is x3, y3. So what we can have here, okay, this is triangle, right? So to get the area, okay, I can actually find the regular polygon that I know. Okay, so from here you can see if I draw dotted line, okay, dotted line, okay, and then I join C to D, okay, then I will get one right angle triangle. And if I draw another dotted line here to E, okay, from D to E, I get another right angle triangle. Okay, means I will get one trapezium here, another right angle triangle here. Now to get the angle, or sorry, to get the area, alright, to get the area of ABC, triangle ABC, actually I can just add up these two polygon, right angle triangle and trapezium. So okay, I add up the area of triangle and trapezium, and then I minus one area of this, okay, the smaller right angle triangle down here, okay, right angle ABE, okay. So this triangle is a right angle triangle, okay, that we can calculate the area using the formula half time base times height. Okay, so the formula for right angle triangle we have learned. Okay, it's a regular one. Okay, means it's easy to get that formula. Okay, and we have learned. Okay, so right angle triangle for ABC. Okay, plus with trapezium. This is the formula for area of trapezium. Okay, half multiply with the height, okay, DE is the height, and then multiply with the length of the two parallel sides. So BE and CD is parallel. So if we have this formula, okay, we can get the area of any of triangle that is on the Cartesian plate. Okay, but one thing here, we see here, okay, one thing that we see here is we need the length of AD. Okay, we need the length of AD, meaning to say, right, AD you have to find, okay, this one, the length of AD, alright, and then the length of DE. So how to get all this length? Okay, you have to do some, what we call that? Okay, how to know AD? AD is from the x coordinate 3, right? So x3, Okay, so the length of AD, okay, the length of AD is A to D, right? So if you see this is the length of x-axis, so we can get x3 minus x1. Okay, so x3 minus x1 is the length of AD. Okay, see? So the length of CD, alright, is the y-axis. So is y3 minus y1. Okay, so that's the length. If I substitute all the length here, okay, I can actually get this one. Okay, so actually this one I get for your textbook, you can just follow one by one. Okay, so after I substitute the length, okay, for AD CD and then I simplified it, I will get this. Okay, so meaning to say, okay, I can just take the x1 minus multiply with y2 after simplifying, x1 multiply with y2. Okay, x multiply with y2, okay, plus x2 multiply with y3, okay, and then plus, and then you get minus minus minus. So this formula is quite complicated, okay, you see. So when we prove this one, it seems like very complicated, but if we go I mean, if we use some algorithm, algorithm means some mathematical steps. Okay, actually we can change this to a simpler way of understanding. Okay, so if we write down area of ABC, if we write down all the coordinates for the triangle ABC, and then we repeat another time. Okay, the A. Okay, we repeat A. Okay, then we do down. Okay, we do the arrow down. Can you see the arrow down? X1 to x2, we multiply. Arrow down. Okay, we multiply like this. You see, I will get this formula. X1 multiplied by y2. X2 multiplied by x3. X3 multiplied by x1. So this is the one. Okay, then in my minus, 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 minus. So that means this one is going up. Okay, so minus. So that's why, okay, by using this algorithm, okay, I can actually it actually tell me how to get the area of polygon using its coordinates. Okay, but one thing here, you see this, okay, this modulus sign. So what is it modulus for? Okay, you can read here, okay, the modulus, the area, okay, is the value of area depends on the location or the position, how we take the angle, okay, sorry, the coordinates. If we take it anti-clockwise and then clockwise, okay, if we arrange x1, okay, x2, x3, this one is anti-clockwise. So when we arrange anti-clockwise, you will get positive. Okay, but if you arrange it negative clockwise, okay, you get positive. So since area cannot be negative, so it's better we put the modulus, okay, so that we will know that we have to take only positive answer. Okay, so that's why we have the modulus, and this is how we make this complicated formula look simpler. Okay, means we arrange the coordinate and repeat the first one. Okay, repeat whatever the first one that you have, you must repeat. Okay, so we will see the next example. Yes, so the next example is here. So I have one triangle, you see. So the triangle ABC. So they are coordinate, of course, ABC. So we just write down the coordinates. Okay, clockwise, anti-clockwise is okay. You see, if I do anti-clockwise, I get positive, right? So -4, -6. So this is the coordinates for point A. Okay, 5, 3 coordinate for B. Okay, 2, 8 coordinate for C. And last one, we have to repeat the first coordinate, -4, -6. Then we follow the algorithm, okay? So now multiply, okay? After we multiply down, okay, we have to minus the other one, the diagonal one, okay? So you get this, and when we simplify, you get 72 modulus. So what I need you to know here, okay, if we use anti-clockwise, okay, you get positive. If you go another way around, you see this one, -4, -6, and then instead of 5, 3, I use 2, 8. Okay, so 2, 8 means from A, I go C. Okay, after that only B. So this is clockwise. So when you go clockwise, you will get for negative value. So the modulus will help us to remove the negative sign. Okay, so when the negative sign is removed, Yes, you will get the same answer, okay, no matter you are using clockwise or anti-clockwise. So that's the use of this modulus. But one thing here, okay, the modulus also will become a problem when we do it backward. Okay, so when we do it backward, so for example here, okay, ABC again. So now see the coordinate is not complete. Okay, we need to find the coordinate of x, but we are given the area of the triangle is 18 units. So 18 unit means we can use the formula, but we now substitute. Okay, the area is given, so we substitute the area value, okay, 18. But since this is a modulus, so we have to remove the modulus. But when we remove the modulus, the 18 will become positive and negative. Okay, positive and negative. So we remove modulus, it becomes positive, negative. So you have to split the working. You have to split. One is negative 18, another one is 18. Okay. So after you split, you get two different answer. Now this you have to see the possible value. That means sometimes there are no conditions given. Okay, so we will accept both, but sometimes we will have to reject one. Okay, for this example, we can accept both because if we draw out, you see the coordinate C. If k is negative 4, this is the C1. Okay, but if k is 5, okay, here is the C1. Okay, the C2 is the position of C. That means there are two types of triangle that can be drawn out with the area 18. Okay, that's why you have two value and both value is accepted. Okay, so sometimes it will not, sometimes yes. Okay, so we have to try and error. I mean, try to fit in and see whether it's possible or not. Okay, if not possible, you have to reject. Okay, so that you have to do your exercise. Huh? Okay. So we'll see one more on the equation of locus. So first thing, what is locus? Okay, so we can go to Google and you will find locus in many definition. Okay, definition for locus in different field. Okay, it has different meaning. Okay, so that one is okay, like just for you to know that locus is not only used in mathematics. Okay, but if we focus in mathematics, okay, locus means a curve or a pathway. Okay, which satisfy the point, okay, where all the point will lie and follow the rules. Okay, so in here we will see two type of locus. Huh? So if I have example, this one taken from the textbook. Okay, so you see this sentence, this statement. Okay, the statement here say the locus is a moving point. Okay, for example, if I have a point A, all right, moving R unit from the O. So you see, this is the O, R unit, A is moving. So A must move in such the distance between A to O is always the same. Okay, R. Okay, so use a little bit of logic here. This A will move in a circle. Okay, so if you think logically, if I want to make sure I'm always at the same distance from a point O, I will move in a circle. Okay, so that is how we understand locus. So locus is the pathway, right? The pathway of this A. Okay, the equation of the A or the pathway of the A made by following the condition, by what we call fulfill, okay, the condition given. Okay, so first we have two example here. Okay, two example. If the locus is the moving point from a fixed point, so the example given here lah. So if I have a fixed point and I want to find the locus of the fixed point of the locus of the same distance from the fixed point. Okay, so I will get a circle. But how to find the locus? How to find the equation? Okay, here. Okay, so we use the formula for distance. So since the distance is always the same, so let it be r. Okay, so locus of P means the equation of this circle. Okay, so I have to get the equation. So P is the moving point, A is the fixed point. So P here it can be any value. Okay, so we let it be xy. See, but since A is a fixed point, so we put A x1, y1. Okay, the coordinate for A is a fixed one, so we put the number there. So then we remember the distance formula. Okay, after that simplify. Okay, so this is how we calculate the locus. Later we see one example with number, then you will be clear. Okay, so another example of locus is on another way of asking locus is about the ratio of distance. So this one is a little bit confusing. Okay, so you have to be very clear on that. Okay, let us see. I'll explain here. Okay, ratio on distance of moving point. So what is called by ratio? So ratio is something distance. Okay, the distance is in ratio, means you have one moving point and you have 2 points which is in ratio. Okay, in a ratio. So let us see. Okay, to explore the shape. So first thing, if I have a question, okay, what is the okay, let the P be the moving point. Okay, so now P is the moving point. So it is this, the distance from two fixed point is in the ratio of m and n. So if I draw out, so I have one locus, sorry, I have one moving point P. Okay, and this P is always moved in such, okay, the distance from B and distance from A, alright, is always in this ratio m to n. So actually if I draw the locus, is also is a circle. Okay, is a circle. Okay, so how to get the equation then? Okay, so since it's a ratio, so we just use the PA ratio PB equals to ratio m to n. Okay, then we use the distance formula. Okay, then make sure when you want to remove the square root, you have to square the both sides. Okay, so we will have m square over n square. Okay, then we simplify, you get your equation. Now if the ratio is 1 to 1, means it's always same distance. Okay, if we change a little bit here, the ratio become 1 to 1, that means it's same distance. So same distance, it means it's not a circle anymore. Okay, it will become a bisector. So you have to think a bit. Okay, draw it out. Okay, it will be bisector. So that means to say if A and B is here and it is always same distance. Same distance means you have to go like this. Okay, right angle at this part. Wait, so it will be here. So this point will be like this. Yes, bisector. So no matter where the point P is, okay, as long as on this line, it's always same distance. Okay, same distance. Oh, sorry, it's over here, center. That one is in the ratio. Okay. Okay, so same distance means it will be here. Okay, so 90 degree, and it will always be same. Okay, from P to B, P to A, same distance. So that's why it says it's a perpendicular bisector of line. Then your equation will be PA equals to BB, and same thing lah. Okay, you will do the from the locus you can know the shape. Okay, from the equation you can know the shape of the locus. Okay, so this is a straight line. So you will see one example of problem solving. Okay, you will ask me why we need to learn all those locus. Okay, so let us see here. If I have a goat, okay, tied, okay, with a rope to a pole, okay, which is planted in the middle of the field, the length of the road is 4 meter. So the length of the road is 4 meter. The goat can only walk around the pole tied to the end of the road, right? So what do you think the movement of the road, the goat? Okay, so we can see, yes, okay, this is the point where it tied to A equals to 2, 4, okay. Then it's 4 meter. The length of the road is 4 meter. So the furthest or the maximum that the road can, the goat can make is one circle with radius 4. So how to make the equation? Yes. Okay, PA equals to 4. You use square root, then you get your circle. Okay. So all I get from your textbook, so don't worry. So you can do the own practice, okay, 7.6 to 7.11, and also intensive practice 7.3 and 7.4. Okay, I will give you a week class. Okay, that's why I share you the video today. So you do your work, okay, until the next Wednesday when you come back. Okay, if you can, I can see you, then we continue the next chapter. Okay, you have to pass out your book. So this is supposed to do in MS 1. Okay, MS 1. So MS 1 you will pass out when I meet you. Okay, MS 2 we will continue with chapter 8. Okay, so till we meet again. Bye. See you again.